Live. We're live. And I wonder why my camera always looks a little to the side, my head. So it feels like if I hold my head like that, I'm straight, but naturally, it's not exactly how I hold it. Anyways, we're looking at LeetCode on a Fluke Saturday. And let's start with an easy problem. Where these problems came from? It's from this Saturday LeetCode group that I try to stay connected with and participate. And so I hope I'm sharing. Yeah. There is this. Let's start with the easy one. Because there is like about 3 problems we had today, and one of them was easy, middle, and hard level. Yeah, level. So let's see what we can do for the easy one. It's problem 2032 on LeetCode, and it's called 2 out of 3. And we're given 3 integer arrays. Return a distinct array containing all the values that are present in at least 2 out of the 3 arrays. You may return the values in any order. Okay, so my brain is like, what's going on? 3 arrays. All right, let's take a look at examples. nums1 is 1, 1, 3, 2. nums2 is 2, 3. nums3 is 3. And the output is 3, 2. Explanation. The values that are present in at least 2 arrays are 3 in all 3 arrays, 2 in nums1 and nums2. Okay. All right. Example 2. nums1 3, 1. nums2 3 and 2 and 3. nums3 is 1 and 2. Output 2, 3, 1. The values that are present in at least 2 arrays are 2 in 3 is in another pair of arrays, and num is in another pair of arrays. Okay, example 3, nums1 is 1, 2, 2. nums2 is 4, 3, 3. nums3 is 5. Only 5. Output is nothing. No values is present in at least 2 arrays. Why? So if we say 1, it's only in 1 array. 2 is only in 1 array. Okay, and the same thing. So yeah, so if we have at least 1 repetition, that gives us at least 1 repetition. That means, repetition among the arrays, not within 1 array like this, but repetition, yeah, so in another array, that we need to include. Now I think I kind of understand it kind of better. So we will see, okay, so this in this array we have number 1, but it's not present in any other arrays. We have number 3, it is repeated. Number 2 has 1 repetition as well. That's why we need to include those. But And what are the constraints? The numbers are, okay, the lengths are up to 100 and the nums are up to 100, starting with 1. Wow. Wow, I'm thinking of a very straightforward solution here. Why not? Yeah, just a simple solution. Why not we have an array, nums, which is actually gonna be the frequencies. It's frequency count. It's going to be a slice. If I could only spell the word make, that would be fantastic. And that slice is going to be of length 101. We will use indices of that slice as our numbers. They represent corresponding numbers because we only have 100, but we do need to have 100. So we need an index 100. I mean, we could use map for that also, a hash map. But if we use a hash map, we will only, that will allow us to only create values that are actually present. Essentially, yeah, we could use both. But in this case, I just feel like I want to use an array. It just because there's limited number of, but I mean, we can redo it and use a hash map instead. Anyways, what we want to do next is we will go over nums1 for, we don't care about indices, range nums1, and we're going to look at a number and see if it's in frequency count. And by the way, we'll also need our result. The result is at least one repetition. So repeating nums. If I could spell repeating, repeat, is that the word repeat? Say again something one has already said. So repeating, yeah. Wow, I can repeating numbers, or the result is going to be a slice of integers. Right. So frequency count at this stage for this number, well, it depends. If what we have there now is 0, we need to add it. And that's the only, yeah, that's how we get sort of a set, yeah, of what's in that first nums1. Okay. Then what happens then? After that, well, it's the first array. We don't care about any other stuff, basically. But for the second array, yeah, we don't know much about, we're not going to add anything. So for the nums2, we're checking if there is one, if it's already there. That means we have a repetition. So that thing needs to go. And by the way, yeah, we have now two cases. If there is a repetition, yeah, by the way, we do need to, if there is no repetition, we need to add it. If it was not in the first array, we need to have it in the frequency now. Else, so if it's already there, then we need to add it to our repeating nums. Is append repeating nums value. Right? Actually, we don't have to do it now. I mean, we could, but we don't have to. What we need if it's already there, we just need to make it. If it's already there, we need to add one as well. So basically, we need to add it. We need just to add it. We don't need to do anything else. If it's there, if it's not there, we're just gonna. Oh, no. Okay, so here is the deal. We only want to add it once. That's the thing. We don't want to add it like in this case, why we added it if it's only 0. Because only if it's 0, because we don't want to add them twice. At the end, what we want to do is count how many we had. So on the second, we're looking for those that are either 0. So that means they have not been existent, or else they're not else if that number has been already counted, else if it's been 1, then we need to count it again. So we have a repetition. Here is the problem. It could be repeating just in nums1, nums2. So, so that's a little bit of a problem, because if we just do it like that, we will, we'll count it by mistake. We'll count it twice out of here. The second array, yeah. And that's not what we want to do. We want to count it twice only if it was in the first array. If it was not, so we have a 0. Yeah, we'll confuse it. We will not know. We will not know that. I'm afraid we need to work with a set from each. Because otherwise, okay, for the second array, we will not, we'll false count it, basically. Because why are we counting it if it's 0? We want to then compare it with the third array. So we're kind of dealing with 3 sources here, 3 pairs. We're dealing with 3 pairs, and we want to okay, so I'm being a little distracted. So this frequency count, it looks like we need it for each, or at least for 2. We need a set for each. Set 1, set 2, set 3 will tell us what's there. That way we will not be dealing with repetitions in so this set, once we have it, will avoid repetitions in the given array. That's the solution. We need to clean those repetitions. They confuse the main question. We need to detect repetitions between arrays, not inside an array. So that's why we would need a set for each one. It seems so. Otherwise, we need to, I mean, how else can you track that this number is a repetition inside that array, inside the given array? Only by tracking the frequency inside that given array. So so it seems like a set is a simple solution for that. Once we have sets set for each, we can do sort of the same thing. Well, a set, we just can go over we can go over the longest set. Yeah, we should probably go over the longest set. I don't know actually if we can go over just one set then. No, we still need to do comparisons between the three pairs. But after we have the set, yeah. So we need to not to repeat the code many times, we should create a function which will be frequency count, which will receive a slice of integers, nums, and return a well, we can do a map, or we can do an array. An array. It's pretty much the same in this case. It's pretty much the same. We'll return a slice of integers, and that's what it will be doing, that particular operation, yeah. And what? So yeah, we'll run this function. Say that set1. Yeah, and we'll oops. So we have three sets now. What happens here? We go over the nums. Well, we first create this array. We go over the nums, and if a number happens at least one, it will get into our set. It's not really a set. It's like a frequency array. It's like a frequency array. What we could do is use a map But that will, I mean, easily return to us the. And by the way, instead of num slice of nums, we could just do a slice of bool and say that for this value, it's now true. Okay. So it, yeah. All right. Now we have the sets. Now everything is only repeated. Yeah, they can tell us that set 1 for this specific value, either it has it or not. Well, it looks like we again need to go over. We need to go over this set 1 for I the range set 1 and so repeating nums, yeah, now we'll have this frequency, this we'll have this general frequency. Actually, since we know there is just 100, we can just do it like that. We know all the numbers that are possible there. So we're gonna say num range 101. When we say that, num will start at 0 and go to 100. 0 is not going to be present in any, we don't care. But I mean, well, to be more clear, we can just say num is 1, num until num is equal to 100, num plus plus. So we'll just go over all the nums, possible numbers, and we'll just check if num is true. Yeah, then we'll just check repetition count. Rep count is 0. If actually ones could be even easier here. Yeah, if we use integers, by the way, if we use Boolean, we don't need to do anything. Yeah, and we don't need to do that. We just go if value is, and whatever value we find, we just update our, yeah, we don't need to check that. Just say that set has it. Yeah, this set has it. That's it. Okay, if this set has it, then rep count plus plus, that's kind of it. And that's what we need to do with all other three sets, yeah. If set 2 has it, so if rep count is more than 1, then we need to add that number. Repeating nums is append repeating nums num. Return repeating nums. I think it should be like that. Oh. Uh-oh. Uh-oh. Count. Oh, bool, yeah. Missing return. Oh, yeah. Return. Okay, there is something is not working, but let's, before we go into and see what the output, so there is a problem. Let's try to find it without looking at the test results. So we have our repeating nums. We have our sets. Frequency. Set goes over nums. It creates, well, actually, this is not a frequency count in this case, yeah, since we're returning, we're not counting them anymore. We're just saying, get set. So the set, we're implementing a set with an array, okay? Our set has Boolean values and we're going over the nums and assigning true to values that exist. Everything else will have false default value. Okay, now we have our sets, and now we're going to go all the possible values from 1 to 100. And we're going to say, okay, how many times was this number repeated in all of our three sets? So if set 1 has that number, then yeah, we start the repetition count, rep count. If it's, and we count it for each. We count it for each, yeah. By the way, we could avoid having all these ifs if we were just using actual frequency count, yeah. Yeah, it will be shorter. Yeah, let's get back to the frequency count, yeah. that we will need to, instead of bool, we have integers. If frequency value now is 0, then we actually set it to 1. So we have that. Those sets. Now all we need to do is just say, okay, then plus set 2 num, plus set 3, because default values will be zeros, and we actually could just say like that, if the sum of these is more than more than 1, if we have at least 2 of them, so that should be working. It works. It works on these tests and should be working on all other tests. Nice. Well, a little bit of a rusty mind this morning, or this is afternoon already, but anyways, so we were doing this live, and the key solution was to remove the duplications within the and then to disregard, to clean up the duplicates, so we can count the actual duplicates between them. And a set was a perfect solution for that. And then we just go over all the possible. We don't have to worry about which one is. I mean, if we didn't do that, we would have to go over each pair, or I don't know, over each nums actually, and separately create that map of frequency map. But in this case, we knew that we are dealing with 100. The range of the numbers we're dealing with, we knew that, and we just looped through that. We're looping through numbers from 1 to 100, and wherever it's in our set, it's being added to the sum of repetitions, and if it's more than 1, we need to add it to the answer. The fact that we can return it in any order suggests we could have used just hash maps to implement this final analysis. Hash map, because a hash map order of iteration, and we will go through that again. Or if we implemented the hash of these with a hash map, so basically we would get random not some order we don't know. So that's why it could work. Well, this seems to be a solution. So, nice warm-up exercise. Let's take a break and maybe come back with another problem. But for now, that's the solution. Thank you for watching, and we'll see you in another video.